delighted to have Dr. Onur Varol with us. He is one of the world's leading figures on like bots and bot networks, among other things. And it's, I think, our big gain that he is coming to Sabancı University in fall to become a principal investigator in the viral lab, his lab at Sabancı University. Dr. Varol is currently at Northeastern University's Center for Complex Network Research, and he completed his PhD in informatics at Indiana University, Bloomington. He, among other things, he basically created the Botometer, one of the first automated bot detection systems on the internet. And many people that I've seen has used that Botometer that Dr. Varol created. And his team ranked at the top 3 of worldwide at 2015 DARPA bot challenge. So again, he's one of the best people in the world to basically talk to about bots, social networks in digital space. And today he prepared us with a tutorial. So Dr. Varol, the floor is yours. It's incredible to have you with us. Thanks for accepting our invitation.
Thank you very much, Akın Hocam. Thank you, and thank you, Emre, for also helping with the logistics and making this happen. I'm really happy to be part of like the Turkish computational social science community, being able to meet with you and share some of the results. And I hope it's going to be a fun day for us, for all of us today. So the type of material that I prepare is like mix of both some of the presentation and background and some of the codes that I share through GitHub. If you had a chance to see it early on, that's great. Otherwise, we will also go through them step by step. So what I did was like, I kind of pick one interesting subject that is happening nowadays and then use some of the tools I believe you might also like to use in your own research and make a step-by-step work through, and we can discuss, and please ask me like if you have any question at any time. So let me first share my screen for the slide, and then we can switch back again to present for the codes as well. So as Akın Hocam mentioned, like my research has been related to detecting social bots and analyzing online conversation, which includes elections and political conversation or social protests. And I've been doing other type of research for understanding like human behavior using online data. And it was great, like before this session, you had the nice conversation discussion part about the networks. And we rely on networks a lot for us to be able to understand like what type of data that we have, having a high level overview of the interactions that we might observe. And in many cases, getting a novel perspective. So these are like some of the interesting networks that I like by myself. So like one in the left top is looking for the disease networks, how different diseases are related to each other based on the disease proteins that they might have. The right top is a flavor network they call, so they look at different recipes, food, and they analyze the ingredients. So if you have, I don't know, a certain dish and it has eggs, onions, and tomatoes, and another dish with eggs, onion, but something else. So you can build such a network based on the ingredient similarities, and you can create this interesting flavor network where you can see certain clusters. One cluster might correspond to certain cuisines or cultural preferences. So then it gives us a really large overview to study such cultural networks. Or looking at the brain as a network for different parts of our brain, how the electrons, how the neurons are firing and how strongly coupled they are. We can understand the brain dynamics, we can study brain dynamics. Or like in the left bottom, they have been looking Wikipedia. So in Wikipedia, different pages might have different versions in terms of languages. So if a page is really popular, it might be translated into various languages, 40, 50 available Wikipedia languages. So they are looking for those shared pages. So the pages that have multiple language edition, they look for how different languages close to each other in terms of what concepts they share in their languages, and then they can build these language networks. So how much different languages share the common knowledge. Or the other was like a translation network in the beginning. So in the middle, so they look for different cultures, and they pick like 5, 6 common words like sun, moon, water, and things like that. So one can assume people are aware of them early on from the history. And they translated back and forth between English to other languages and with each other to see how conceptually they might be similar or different. So those networks can also be useful for political science as well. We can look at like how online polarization, or we can look for communication patterns, how they different from each other. So the left one is a retweet network on political conversation in the US. So what is like really interesting to see is the red dots and blue dots well separated from each other, because people tend to reinforce the conversation among each other. They support each other's opinion. They keep retweeting people thinking in a similar way as they do. So Republicans are retweeting other Republicans, Democrats retweeting other Democrats. So that creates this segregation and high modularity on these networks. But on the right, this is conversation network. People are responding to each other, replying to each other. Then we see not so strong separation. People are still trying to talk with each other, although the retweet network is much more strong to separate, create this polarization. And this is one way of like looking online data and study those networks. And so internet is kind of like a new platform, new avenue for us to discuss, but such discussion, such political communication is not new. So since the early 1700s, there were newspapers, telegrams, and this helps people to gather around for public speeches. So people get to know when an event is happening, and they use these different communication media to get to a place. And then with radio and telephone, it became much more popular. So then even the
Onur Hocam, we couldn't hear you. Yes.
Okay, can you hear me now?
Yes, yes.
Oh, okay, sorry. So I was saying like different mediums have been changing the way we interact and communicate. So with television and radio, that bring a different opportunities. We can see first debate happening online, or the first political advertisements aired online. And with the internet, it is a totally different story. With internet, we started to see not one-to-many communication, many-to-many communication. Now, I'm not only listening to politicians' opinion, but I can also share my opinion and get a support from others. So then internet really boosts the political communication in that sense. And we can see debates happening online. We can see politicians are answering questions online from millions of people. And it also affects how we politically behave, our voting behavior, our political conversation as well. And such networks, although they are really good, there's also chances that some malicious actors can also play a role to manipulate the conversation. Like 2 examples that I gave is like one of the top figures showing a spread of a fake news on Twitter. And that was like a really weird article. So the claims people have been making on this article is outrageous. They claim Clinton is a part of some bizarre occult ritual. They are kidnapping kids, drinking blood, and things like that. So totally outrageous stuff. But it became really widely popular on social media, spread across thousands of people. And when we start putting this in terms of like a network, who are the social media actors that create those content and share it, what we start to see is some of these content disseminators are actually not human or organic accounts. They are automated accounts. And in that figure, like the more red the dots is, they are more likely to be a bot account. And we see the central nodes, the ones that have larger size, the more connected ones are usually those red dots. Similarly, another big debate, not debate, but I mean, online conversation is the vaccination policies. So there's a big group of people in US, they don't want to vaccinate their kids. And there's a community around that. They've been talking misinformation, why vaccination is bad. They claim vaccination can cause autism and things like that. And in this network, when we sketch out for the actors disseminating those information, we can see similar patterns as well. Most of these dots in that figure, those users with high degree, they also social bot accounts. They also well connected, but creating those content automatically. And so network thinking, sketching those communication mediums online through networks give us like a first visual cue. Then we can dive into the data to look more in details. And this is a recent example. So what we used to see like popular accounts or automated account using their popularity or influence on the network, mostly for disseminating misinformation or spam type of account. But what BTS does recently is quite interesting. So they use their popularity, which they have like over 26 million followers on Twitter, for a good cause. So they start using and inviting their fans to use racist hashtags like White Lives Matter. And they start creating those contents to give some more positive vibe on those communication channels. So they make it unuseful for racist people to communicate through that channels. And we usually see the opposite of those. And this was quite interesting to see in the, I think last week or 10 days ago. And one of the things that we can look at, like how popularity can interplay with the information dissemination, is what I developed called Q factor. So it's it's a measure that you can compute as called Q factor. What it does is it computes a measure between engagement and popularity. It's not simply dividing number of retweets by number of followers. It's a different model than that, but it reveals how well your content resonates with your audience. For instance, anything BTS share with their 26 million followers gets retweeted 500,000 times. Erdogan's accounts have similar popularity levels, so he has 16 million followers, but that content doesn't resonate well. It doesn't get as big impact as the BTS. And part of this might be because BTS content is more music related, more fun content, and then in the Erdogan's case, it's more like a political. So the target audience is also different. Part of this might be because of that. But like another account, like my account, which has 2,600 followers, have only order of 100 engagement. So there's like an order of magnitude difference of engagement. So for instance, Erdogan's account is like 1,000 times more popular than my account, and the content he generated is almost 1,000 times more popular than mine. But unlike BTS, they have the same order of magnitude popularity, but the other content is 2 orders of magnitude more engaging. And this is kind of like the things that we can start looking at. I think for this demo, what I try to do is like picking one interesting hashtag. It can be anything, but recently I've been seeing these Milli Hesaplar Burada hashtag, which means like literally the national accounts is here. So they try to promote people following each other and creating a network on its own. And anyone who sees those hashtags follow those accounts and things like that. So we can explore those hashtags for the sake of this tutorial. And these are a couple of examples that I see online. And some of the things that are kind of like interesting to see is the usernames with lots of numbers, numerical values, or accounts created really recently. So it kind of like steer curiosity on me to understand what's happening, who are those accounts, what they are promoting, what are their role on the network. And first, like for this type of analysis, I can recommend a couple of tool sets, like the Observatory of Social Media from Indiana University is one of them. And they have quite different tools, like Botometer is part of them. Hoaxy is another tool that we developed. It's also used Botometer in the backend to look for information spread dissemination. And with this platform, we also have simple tools like Trend Tool and Network Tool. And with the Trend Tool, we can plug in any hashtag, we can give it a time range, and we can see popularity of those hashtags on the data that we collect. So for this platform, we have a decahose. So we have 10% of all the public tweets. So we have quite a large number of volume in this data source. And one thing that's interesting is like when I look at the trends, actually compared to COVID discussion, the COVID-19 hashtag, excuse me, those two hashtags is getting quite popular. They get almost half of the total COVID conversation volume allocated, dedicated to them in terms of like daily peaks. And when we look at like the interactive network graph, which hashtags are co-occurring which other hashtag, we also see lots of other hashtags are populated with that, within that conversation. So there is some other conversation going on, so we can take a look at those as well. And part of the demo in the next, I will show some of those. And another tool is Hoaxy. So we can also plug in those hashtags and we get the most current conversation online. So it pulls the recent tweets from those hashtags and create a network layout. Who is retweeting who is mentioning who is replying who. So these are all interacting human accounts. And the dots in that network represents also the bot score. So if they are closer to red, they are more likely to be being an automated accounts. If they are more blue, they are more human-likely accounts. So such tools gives us a early glimpses of like what's going on in this data, and we can analyze those initial data to look for like, okay, if this is a promising analysis, should we go further down in this data? And there are some interesting structure on that. We can see like some of these orange accounts, they are close to being bot-like accounts, and they are connected to some other human accounts. So there are some group in the lower end. So they are like mostly dominated by more automated accounts. So I get curious, like let's give it a shot and look at this data. And the first one is, let's take a look at the IPython Notebook 1, and I will just switch to a different screen. Let's see, I think this one. So in this one, I've started like analyzing the hashtag co-occurrence network. And for this, I primarily use OSoMe tool. And among these tools, we have several things. So one of them was the network. And what I did was I used first the trend tool for displaying the trends, volume of activities over time. And I also look for the network tools to visualize the co-occurrence network. And I exported the hashtag co-occurrence network data through OSoMe because there's an export functionality. So you can get an JSON data of the exported graph. And when you look at like a couple of samples, the lines from that file is, what we have is we have the source hashtag, we have the target hashtag, we have a tweet ID, and then some weight. So we can iterate through such data and build a hashtag co-occurrence network. And this is the part like where we were building a hashtag co-occurrence network using a Python package called networkx. So we iterate through different hashtag data and we create an edge between source and target. And our resulting network has over about 449 nodes and close to 10,000 edges in between. And if you look at like the degree distribution, so which nodes are the most popular, so milli hesaplar yan yana is the most popular one, milli hesaplar burada is the second most popular, and things like that. But this is kind of expected since our initial seed was these hashtags. So it is not surprising to see they are the most popular ones. But we can also create those network and explore the network visualization as well. And let me share screen, switch back to another screen again. So this is the hashtag co-occurrence network that we can get from this analysis. So I applied the Leuven modularity maximization network layout. So there were several different communities. We see like some pink color that are totally irrelevant to the subject, but there are bot accounts try to piggyback on conversation. So they try to gain from the popularity of conversation. We see some culture-related hashtag as brown. We see a followership network on orange, like people are trying to ask for getting followers. So if you follow me, I will follow you back type of negotiation. And there are some religion, politics related network layout as well. But how we get to that? So let's go back again. Sorry for the back and forth, by the way. Okay, so this was the overview of the network. So first thing that I did was, since I had this network, I can compute different centrality measures. So I pretty much list most of the centrality measures that could be useful, like the degree centrality, closeness centrality, betweenness, page rank. I compute local clustering coefficients. I compute the click number, which I will show like where it can be useful. The core number and the onion layer. So those are different measures that can be computed in the node level. And we can look at different hashtags and what type of scores they get through these different centrality measures. One of the things that is interesting is like this hashtag hijacking event. So anytime a hashtag gets popular or it becomes a trending topic, bot accounts or other accounts tend to co-occur this hashtag with others. So they use those hashtags to increase their popularity in case other people are seeing those hashtags and promoting those hashtags. And the high click number is revealed that. So there are those tweets with 20, 25 different hashtags all co-occur together. Pretty obviously they're created by social bots and they try to piggyback on those popular hashtags to push their own content. And one of the structural feature one can realize those networks is they tend to connect all of them with each other. So that's why I rank them by click values. And the highest click values is like some pornography related cluster, which we also see in the network layout on the orange. So when I was looking, I didn't list all the hashtags because some of them are really graphic, but the top 25 was about pornography. And then the range between 25 to 50 is about religion. So they have been using these popular hashtags to increase their own visibility and popularity. And we can select a core hashtag for going further down with the analysis. And one of the ways we can choose is based on the degree centralities. Another way is like identifying whether certain patterns. And what I did here for the sake of simplicity is looking if they have certain keywords within a hashtag. So I look for anything that has milli and hesap, so which they are like national and the accounts. And this was my core hashtag list. And the second stage is we can dehydrate those tweets. So let me go to second notebook. So this is the dehydration stage. And what we usually have with these type of social media data is we can collect those hashtags. And I did cheat a little bit here because I go back to my own data sources where we have the Decahose access and collected all the tweet IDs with one of these hashtags. And in the GitHub repository, I upload these tweet IDs to Zenodo platform. So you can click here and have a chance to download it through the platform. So it was a large file. It's about like 120 megabytes, which is over the limit of a single file that I can push on GitHub. So you might need to download it through here. But since you have tweet IDs, nothing can stop you to collect the actual content of these tweets. And Twitter terms of service also allow researchers to share over 1.5 million tweet IDs with any entity. And for research, I think there's no limit for that. So that's why it is okay to share those tweet IDs. And there are tools like Dehydrator, other software packages to collect the content for those tweets. Here, I just use the TweetPy package, which is a Twitter data access package you can use on Python. So what it requires is the Twitter keys, the consumer keys, and then the access tokens. And the type of keys that you can create is in the config file here. And please let me know like if I'm going too fast or it's not clear. So in this config file, I created this dictionary where you can collect these Twitter keys through Twitter developer platform. So once you have these 4 information, you can use this TweetPy package to access to the data. And what I've been doing is like I iterate through all different tweet IDs in that file and collect the tweet content one by one for all of it. And at the end, I think I have about 240,000 of these tweets. Some of them were not available. This might be because either account is deleted or the account might go to a private setting or the tweet itself get deleted. So this is the file that we can download and use.
Excuse me.
Yes.
What is the rapid AD or rapid APK in your configuration file?
Yeah, let me share my desktop. I think it will be easier. So the Rapid API is the platform. So we have this Botometer API, and Botometer API is hosted on our server. But since our tool is popular, like we have been getting almost 500,000 queries each day, it is really hard for us to handle abusers or the people using multiple IP address or using different number of account keys. So Rapid API is a platform to help us to rate limit those accounts, and it also has mechanisms to monetize those APIs. So Rapid API key is like you enroll to Rapid API platform, you get this key, and you can make a request through this key. Rapid API says, yes, Burak has been making 2,000 requests in the past 24 hours. So this is the maximum limit. So we no longer let him continue asking more requests. So it handles the rate limits and it handles the account management. So they literally make our life much easier.
Thank you very much.
Yeah. So, and I think it's a nice point to talk a little bit about Botometer, because the next part is like how we can analyze social bot data. So Botometer is a platform for identifying social bot accounts. It's been around since 2014, so it was part of my PhD dissertation, but we have been evolving it over time. So recently, in the next month, we will be releasing version 4 of Botometer. And each time we try to improve, we improve the data sets, we improve the novel bot accounts, we improve the machine learning methodologies. So it's an evolving system. But basically, for the functionality, what it does is anytime someone gives a Twitter account, in that case, my account, it computes a bot score in the backend. And it provides a score between 0 and 100 for visualization. In the website, we use 0 to 5 score. And there are different subcategories, like in my case, my content and sentiment features are around 1. It is still human likely. For certain accounts, these scores can go really high, up to 4 or 5. And this is a supervised learning framework. So I've been extracting over 1,100, close to 1,200 features from the available social media data. So what I've been doing with Botometer is I'm making 2 requests to Twitter API for each account. One request is asking the most recent content by that account. So we receive 200 recent tweets. And I also ask for searching, like who other accounts these, so searching query, in which context this user's screen name has been used. And we extract features from user metadata, network structure, friend metadata, some temporal characteristics, content and sentiment, but content and sentiment now available only for English language accounts. So that's why we have a separate model called universal. So the language independent model, which doesn't take into account the content and sentiment features. But hopefully in the next year or so, we are planning to deploy a different version of Botometer, which can support also multilingual accounts and make use of those content information. So it has been using some ensemble methods like random forest. So, and here we can see like how much different sub categories can help for classification accuracy. So in that benchmark, the user profile in the right figure, we see when we use only the user features, we get a decent AUC. And In case you are not familiar with the AUC is a performance measure for supervised learning algorithms. And what it captures is looking how well separated, just a second, how well separated those human and bot accounts. So if it is close to 1, that says the scores for human and bot accounts are well separated. If it is 0.5, they are all scrambled, shuffled with each other. So the classifier doesn't really separate what is human and what is bot. And is there any question? Okay, let me.
Yeah, Ezgi has a question.
Okay, so Ezgi has a question, which one is more common in hijacking hashtags? People who wants to make political propaganda using popular culture hashtag, or popular culture fans use political hashtags to get more followers? I think it can go both ways. So, and it really depends on who is kind of like creating those accounts. So the most of the cases, what I see is people are using political hashtags to piggyback them on, because political conversation is more common, but the other way around can also happen. And sometimes people are hijacking these hashtags with misinformation content as well. So there was a really interesting case about 3 years ago in Mexico. So there was like 20 university students get lost. So they got kidnapped, and then eventually after that, they got killed. And the people from Mexico started, they created a hashtag called Yamekanze, and which literally translates to that's enough. And after they create this hashtag and start complaining and creating a conversation around those hashtags, certain entities start pushing bot-generated content in the Yamekanze hashtag. So they started to increase signal noise ratio, lower the signal noise ratio. So there was lots of pollution in that hashtag. So it's literally impossible to read the actual tweets other than lots of noise. And then people did like a really interesting thing I find like quite fun, is they switched to a Yamekanze 2 hashtag. And then same thing happened, like bots flowed into that hashtag and start polluting it. And then they switched to Yamekanze 3, Yamekanze 4, and it went until Yamekanze 20s. So this is one way of doing it. But I think for increasing, like getting into trending topics, people do all sorts of things. So I think both way can be possible. So I think politics can also use some of the popular hashtags as well. So I think depending on how they design those campaigns, it can happen in both ways. But I see mostly the other hashtags piggybacking the politic-related hashtags. And okay, so if we go back to Botometer, what we also can do with such tool is we can do large-scale population characteristics. So what I did was I trained 2 separate models. One is more sensitive to the bot accounts, the other is more forgiving. And we use this to estimate what's the fraction of bot accounts in an active English-speaking Twitter ecosystem. And our estimate in 2017 was 9 to 15%. And at the time when we published this paper at ICSSM, it made an interesting like media conversation around that as well, because at the time, Twitter was releasing their reports for their investors, and they were claiming only 5%. And the way they were measuring 5% was looking at the active accounts, like if an account posts anything in the past 3 months, or if an account log into a platform at least once in the past 6 months, and things like that. And these are really optimistic measures. So when we made these 9 to 15% estimates, people were thinking it was high, but eventually, like just after a couple of months later, Twitter started to become more aggressive in deleting bot accounts. And they deleted 45 million accounts in just 3 months, which kind of corresponds to 10% of the active Twitter population. So which kind of like aligned with our estimate, which was really nice to see at the time. So, and as I said, like the Botometer is an evolving system, and we try to catch up with the recent challenges with that. And one of the challenges that we have is there are novel account behavior. So we train on a data set. Supervised learning algorithm can capture like what type of humans and bots they observe. But anytime there's a novel bot behavior that we never encounter, our models tend to perform poorly, performance gets deterioration. So that's why we run a set of experiments looking for out-of-domain performances. So these are machine learning models that we train only a subset of data and test it to a different data set that we never see. In certain cases, these models can perform well. In certain cases, they miserably fail. So that's why this is one of the challenges that we try to address. And we can do it in two ways. One is by data augmentation. So by tuning what type of data that we want to present to the classifier to learn better on certain instances. Or the other, which will become the Botometer version 4 in the upcoming months, is using specialized models. So previously we had one large supervised model that consumes all the available data sets, and through the ensemble models, learn different decision rules for the random subsets of those accounts. So with the specialized model, we did something different. So we train a different model for different type of bots. So if there's a one type of bot for spamming, we have a specialized classifier for that. If we have a let's say celebrity who kind of like promote themselves using network automation, we have a special class of that. Or if they are more sophisticated social bots, we have a special class of that. And then through an aggregation, we identify a final score for those. And I think we have a question. How you are, okay, Burak Öztürk is asking how you are using supervised learning model, how you are sure that your labels are correct for Twitter users. That's a great question. So supervised learning framework relies on the features extracted from the data. So those are the information that we use our model to fit, but we also need the label. So we need a supervision to say whether an instance is human or bot. So far, what we have been doing is manual annotation. So we ask 2-3 different independent annotators to label different accounts. And then if they agree in the majority of the cases, we can say, okay, this account is human or bot. And we also evaluate how much the annotators are agree with each other. And this is a common approach. So we measure inter-annotator agreement scores. So let's say we have 5 annotators, 4 of them are agreeing in most of the time, and 1 annotator doesn't agree with others in most of the cases. So maybe this annotator is not reliable. So we can exclude those annotators from the data. And then for the instances, we look for the agreement. If 5 annotators, 4 of them say human, 1 of them say bot, maybe we can label this as a human account as well. And one of the recent challenges that we have is also maybe some of the accounts that we have labels for as humans or as bots might not be correct, because more sophisticated bot accounts are also harder to distinguish. So we have certain cases the humans are not really agree on the label. And so far we ignore those instances from our training data, but actually those are the data points that we need the most, because those are the most significant ones that we want to perform well. And a good thing is like this ensemble approach is actually really helpful in that scenario, because what it does is we have different submodels, and one of the submodel can really good at identifying spam bot accounts, but the other has, let's say, more sophisticated bot accounts. And labels for sophisticated bots might not be the perfect. And since this is a voting approach, one model can fix the mistakes in other data sets labeling, because if a model trained on a not perfect data set, the model is already compromised. So they learn on the wrong labels. But other models never see those labels, so they can really improve and correct the mistaken, misclassified instances. So it even helps human annotators to improve the quality of data sets. And this was like one of the advantages of the specialized model. So since we talked a little bit about Botometer, so let's go this IPython notebook, notebook 3, to talk about like how we can work with the Botometer scores for your research. Let me open this new notebook. So one thing that I really want to accomplish early on with the Botometer is like making it really accessible, really easy to use for everyone. And that's why we develop a Python package. So we open up our API with everyone with the Python package, and you can make queries over time. And so it's really easy to use. And we also share lots of other resources for that. So I really believe in open science, and I think everyone should be able to benefit from those resources. So one of the things that we have is bot repository. So we are sharing all our data sets publicly. So anyone can go and collect those data and train their own models. So we have in the data set, we have all these data sets that we have been using for training Botometers. So one can, in theory, use this data to train another social bot detection approach. And just a second. Okay. So previously we dehydrated those tweets, and I store them in a JSON file. And so in that file, I have all the tweets having one of these hashtags that I care about. And for each tweet object, the nice thing is they can also store the user object at the time of data collection. And I can get certain information about Twitter users. I can get their screen name, name, number of followers, friend status, account creation or account age. And I think we have a question. Oh, okay. So Ezgi is asking, what does dehydration mean exactly? So dehydration is, I think, kind of like a technical term used for if you have a tweet ID. So if you have an identifier, how could I collect the actual content from that tweet ID? Because of Twitter's terms of regulation, sometimes it is problematic to share all the data, and these data also consume lots of space. So sharing the tweet ID is much more easier than sharing the entire content, assuming that one can collect these data by themselves. So what we did for that practice is I collected tweet IDs from my Northeastern resources and share this tweet ID with you on the GitHub repository. And one can run this dehydration code to collect back the data. So here, like, oh, sorry. This dehydration notebook to collect this data. So in this file, tweet ID collection txt, each line is a separate tweet ID. These are usually up to 11 character numerical numbers. And here in this part is the collection part. So I've been reading those data, and in the Twitter API, TweetPy API, there's a method called status lookup. So I can call this function and give them a bunch of tweet IDs, at most like 100 in this case. That's why I divide these tweets IDs into groups of hundreds. So once I provide these 100 tweet IDs, I return back the original tweets of these 100 tweet IDs. So I can get the content itself. And actually, let's kind of like plot one of those to see what we have in it. So this is type of data that each tweet contain. And if I do actually, let's see, instead of JSON, if I print line, no, okay. Let's do this. So this is the tweet data that I have. And what I can do is, I have this JSON editor, which I find it really useful. So, and you can like explore such tools. So what this simple tool does is, once I have a single line of JSON object, it can visualize it in a more structural way. So for us to see what is available. So from a single tweet, what available is we can have a creation time. So this particular tweet is created in May 10th in 2020 at 8 p.m. And then I have the tweet ID. So this is the ID that I use to collect this specific tweet. And then I have the text. So what is written into this tweet. So tweet text can get up to 280 characters. And this particular tweet has only the hashtag, nothing else. Twitter has this other field called entities. So from the entities, I can get an easy access to each hashtag in the text. So that makes it more accessible. It will prevent me to parsing these texts. They directly give me what are the hashtags. There are symbols in some cases. There are user mentioned, if anyone mentioned, or URLs. So in that particular tweet, we don't have any of those. There's a source information, which is really useful. We can use it in this tutorial. So we see what is the system that's responsible for posting that tweet. And this tweet is sent from a Twitter for Android application, probably someone's Android phone. So if this is a tweet replying to someone, we can see these fields are fields. So we can get the user's ID that we are replying, or we can get the tweet ID that we have been replying. And we can get some other additional metadata. We can get like how many times this content retweeted, how many times this content has been favorited. Language used to be an available feature. I think Twitter is no longer supporting those language features. And the other nice thing is each tweet came with a user object. So now I know a lot of information about the user responsible of creating this tweet. So I know the user's ID, I know the user's name, I know the screen name, I know the profile description, number of followers and friends that account has, how many content that account favorited, and how many content the account posted in total, and some other profile related information as well. So we have this type of data, and everything that we can do is kind of like bound with this data. We can collect some additional data about who follows who, but those are really expensive queries. So crawling an entire social network structure on Twitter is really expensive process. That's why people has been using the communication as a proxy to social network structure, which is not always true, but it is an easy way to get a sense of like a network. And so going back to these dehydrated tweets, what I did was creating a user profile. So I pick up some of the information that I believe might be useful for my analysis, like name and screen name information, some of the network-based features, and then the account information when this account created. So I have such a data table that captures most of these essential information for my analysis. And we can look at like some simple measures. We can look for the distributions of post counts in the account profile. So we have very few users over 100 posts, and there are lots of users that are one or few tweets with these specific hashtags. We can look at their number of followers. So most of our accounts have around 1,000 followers, We have accounts with about 1,000 friends. So there's a good balance between number of followers and friends for main accounts, and number of tweets that they have been, produce in their entire timeline. And this is also about 1,000 tweets per account. And we can look for fraction of posts that has these milli hesaplar hashtags, set of these hashtags in their content. So there's also some fraction, like some accounts, about 100 accounts, all they post was about this campaign, the other not so much. Another way of visualizing similar data is like looking all the accounts, all different dots above this blue line. Is 1% or more of their content is actually about this milli hesaplar hashtag, about this campaign, but not many post more than 10% of their content. So it is not like extremely popular hashtag, or there is dedicated accounts. Their sole purpose is boosting those hashtags. We don't see many of those. But it is still interesting to see who are those accounts and how we get a bot score for them. So this is like how easy one can use Botometer. So with the Botometer package, we initialize the our first class object to make the Botometer call. So there are some parameters like wait on rate limit is true because Twitter is applying some rate limit for collecting data. And if Twitter says you can no longer collect more data, I just want this code to run and wait when necessary. The Rapid API key was one of the questions. So this is a required parameter to be able to make these calls. And the Twitter keys, because the Botometer package first collects the tweet data using TweetPy, and then send this tweet data to Botometer server through Rapid API to be able to get the score. And then we can check the account. So the function is check account function called check account, and we can provide either the screen name or the user ID. And this is a type of result it returns. So I get some user metadata. So I know the user ID and screen name. So this is my user ID, and this is the numerical version of my username corresponding user ID. We have the scores. So we have the score of 0.18 for my entire Botometer model, considering the content and language. So 0.18 is really close to 0, and I'm glad to say like I behave like a human on Twitter. And the universal score, which ignores my content and sentiment feature, is also giving me a really close score. So I'm still behaving like a human on that direction. And we have different categorical features. So these are the models that if we want to employ only a subset of features, so I can get my Botometer score if the model only sees my user metadata, or if they only see my friend metadata, or if they only see my content metadata. And these are different submodels that we also train on to give us a sense like why a certain account might be behaving more like a bot account than human. Is there any question up until now?
I think there are some questions in the chat section, which goes back to, I mean, maybe you have already answered them. If you could like scroll up to 4:51 p.m.
I think these are my local time in the chats.
Oh, sorry. Sorry.
So I think I answered Ezgi's questions and Burak's questions.
Mm-hmm. Okay.
But if there's any other question, I'll be happy to answer them as well.
Yeah, I mean, everyone can basically ask their questions via chat. That's what we do. Mm-hmm. So if you guys have questions, feel free to type into the chat section.
Mm-hmm. And maybe I can put these aside as well so that I can see as they come. So yeah, so this is like an example way of like how we can use. Is there a new question? Okay, so I think this is a new question. So Burak is asking, what do you see as a feature for bot detection? Your model we need to based on feature engineering, or the more reliable data you will increase your accuracy. So feature engineering is definitely an important component of it, but at the end of the day, it really boils down to data, quality of data that we have. So if we have some inconsistent data set, the model cannot learn on that data as reliably. So one thing that we try to push forward is how we can collect more reliable data through human annotations or other sources to make our model to perform well. But the features are also really crucial. And for the Botometer, the reason I have over 1,200 features is I designed Botometer not only for social bot detection, but I was thinking at the time is more general purpose classifier for social media accounts. So we never put it on public, but I have a gender detection system. In this case, instead of labels being human or bot accounts, we have the gender accounts. And we mostly rely on user profile, content, and sentiment features to make this decision. We have another model for organizational accounts because it is important to separate if a CNN account versus my account is behaving differently, because the organizational accounts has a team of social media managers that control those accounts, and their behavior is much different than an individual account in terms of like content creation or sharing the information. So that's why we have a bunch of these features, but not all the features are really useful for social bot detection. So I think we can boil it down to 50 really relevant, useful features. But the other thing is social bots are keep evolving. So maybe a subset of features is really good at identifying spam bot accounts. Let's say for spam bots, okay, the number of URL, number of hashtags in the tweet is really clear identifier of spam bot accounts. But maybe the advertisement bots or other persuasive accounts might use the language differently. And then in that case, the part of speech tag for identifying positive adjectives is a strong signal. So that's why the ensemble approach succeeds, because in the ensemble approach, different subclassifiers learn for different data sets and also put different importances for different data sets as well. So the set of features, the most informative features are also different. Nice that if you can ask that people whether they are bot or not to have a ghost data. True or not? Yeah, not always. So many cases, the bot accounts might say, hey, why do you label me as a bot? I am human, but we cannot really rely on that. And for Botometer, we also have a feedback feature. So if you think like the evaluation for your account is not true, you can say, hey, your system labeled me, flagged me as a bot account, but I'm actually a human. So you can provide that feedback to us, and then we can put our manual annotators in charge to decide whether your feedback is correct or not. And then that will also improve the system. But it's a big question, like how we can collect reliable data. It's a challenging one, considering like over time, we started to see more convincing social bot accounts. They have been using image generation, text generation, conversational AIs to make it more convincing. So then I think the boundaries between human and bot accounts is getting more blurry. And I mean, my account is partly bot as well. Not now, but a couple of years ago, I have been using a script to grow my social network. So at the time, my network score was high because I was following and unfollowing people, and I sometimes follow like people not necessarily in my social circle. So then we could see an indication of that. So maybe as a human, I can say, no, Botometer is saying I am bot is wrong, but actually what I was doing at the time was an automation. So Botometer could capture that as well. Although an account belongs to humans can still use automation. So that's what we try to also get with the Botometer. And Matthew has a question, can you compute some error margins or estimates on the accuracy of bot or not? Have you seen some papers using these kind of tools to analyze overall validity further? So that's a good question. So what we does for evaluating Botometer is we definitely use like the supervised learning techniques for training those. And we use cross-validation. So in our training data, we do 5-fold, 10-fold cross-validation to get a sense of how much our AUC fluctuates in domain training data. But recently, what we have been realizing is the recall for the out-of-domain accounts. So if we don't show any of the examples for existing bot accounts, such systems can have poor performance for the novel instances. And this is not specific for Botometer. This is common for any machine learning system. If you think about the debates like the fairness in the machine learning algorithm, like the face recognition applications can't recognize black females in their system, is partly due to such errors. So in the training data set, they don't see such instances, and then the models deployed online might not be performing well. And these are like terrible mistakes that they have been doing, and we try to overcome such challenges also for social bot detection. So I think a couple of evaluation metrics like sanity checks for the model. The first and easy one is like in-domain cross-validation performance evaluation. The second is out-of-domain performance evaluation. And maybe some temporal, like if we score an account as human past, do we continue seeing it as human as well? So these are different things that we can be creative, like how we evaluate. Yeah, I think that can happen, Emre. So if you are not an active user, you might have a higher bot score. I don't know how high it was. And the part could be, since your account, I'm not sure if you are using Twitter in English or Turkish, but if your profile feature says your language is, primary language is Turkish, we might not be using content and language features. So we might only work with the temporal information, your user metadata and user profile metadata. So then we don't have too much information. And since you are an inactive, so the chances of you label not organic human might be higher as well. And okay, Ezgi says, if you say that around 10% of all Twitter accounts are bots, I guess it's not enough that Twitter recently did and delete 7,000 accounts in Turkey. What do you think about this recent issue? Do deleting bots cause creation of smarter bots? Okay, that's a great conversation. And I actually have a one additional notebook that I haven't shared yet on GitHub. So this is actually analyzing this specific data set. So once we get there, I'll be really excited to hear everyone's opinion and we can have a nice conversation on that subject. So it's gonna be a cool conversation. Okay, so Burak says, would it be logical to increase the class labels you have for bot detection? For example, automated accounts, trolls, etc. Does that could increase? So this is partly what we do with the ensemble approach, the specialized models. So in the specialized models, we have different classifiers for different type of bot accounts. We still communicate through the Botometer API as a single score, but we know which classifier is actually responsible for making the decision. So we can say, okay, we are saying this account is bot because the troll model say it's a troll-like account. So it is possible, but we haven't released that functionality yet on the Botometer system. But I think AUC might be a different story. So AUC might be high or low for specific specialized model, but out of wild, when you deploy a machine learning model to a living system like as Twitter, we really need to be careful. That's why the Botometer project is so exciting to me, because traditional like machine learning people, computer scientists, they evaluate their model in a controlled environment. And once they measure accuracy, AUC, precision, recall, F1 score, and things like that, they have a control on which data they train on and which data they test on. But systems like Botometer, it deploys outside, and we have no control what type of accounts that we have been seeing or what changed since we deployed the model. So that's why these out-of-domain experiments are really important for us to be able to get awareness of like when our models start losing the performance, or when there are novel type of bot accounts that we need to address. So it's a never-ending challenge. So anytime the simpler bots become inefficient or they can get detected by social bot detection, people who create those bots are also getting smarter. They also use current techniques to improve their model. Like nowadays, GTP models for the language generation is a big thing in deep learning community. Such a large embedding model, one can create a really realistic conversational agent. So in the simple bot accounts, that's weren't possible. Like even if you realize an account is a bot account, and if you reply their content and say, hey, are you a bot, or this content doesn't make sense, or even if you believe the content is generated by human and you try to get an engagement, you don't really get a reciprocation. So they don't respond to your content. But with the current bot systems, they can do that because they have been using these conversational AIs. So that means it is a little bit challenging nowadays to identify such systems. That's why we try to improve over time. Okay, so this is the part of the code that we have been collecting the Botometer scores. So I'm storing them in this file, which is also available on GitHub. And this is basically use the Botometer API and collects all the data. So here I've been checking all the existing collections so far. And that part of the code is collecting Botometer scores. So I'm just triggering the function for check accounts, and then I give the user ID and I get the result and save it in the file. So it's really intuitive once you have the user IDs or the screen names to collect such data. And for that, I collected about like 65,000 of those accounts. And we can look at like a couple of things. So the first thing that we can look at is the bot score distribution. So in this kind of like a grid-like figure, what I have is the actual original Botometer score for using all the features. And I have a bot score distribution for accounts ignoring the language and content features, so for non-English accounts. And these are the scores generated by different subclassifiers. So what we see, let's focus on this blue figure is, if we assume all the accounts that has greater than 0.5 at the Botometer scores are bot, we have about, let's say, 20% of the accounts in our data set seems like bot likely. So this is like all the accounts on the left of these 0.5 threshold, we can consider them as bot likely behavior. And this is one way of kind of like quantifying the percentages of bots in this data set. But since we are not looking to an entire conversation, measuring fraction of bots in that use case is not like a really ideal. But what is interesting is looking what are these bots are talking about, who they interact with, and things like that. And okay, so before going any further, do you have any question before that about the bot scores or what we can do with that? Because later on, I start using these bot scores and do some visualizations with that. Okay, so one thing that we can do, and in the morning, Matthew was giving examples of like how we can visualize those networks, and he mentioned different layout algorithms. Force-directed layout was one of them, and Freiter. Okay, I couldn't remember the exact name, but there are different layout algorithms for those where they locate the nodes with different rules. And recently, different type of models are also getting popular. So for network layout algorithm, what we have is each individuals and how they connected to each other. We can think of it in a machine learning sense. We have these accounts, and each account is represented as a set of features. So I can compute a similarity matrix between all these accounts. They are fully connected, and one can also try to visualize it as a network, but visualizing fully connected network is not ideal, but people have been using the embedding methods to create such visualization, and one of these is called UMAP, and there are TSNE and other visualization techniques as well. So for that one, what I did was I get all these user friend network temporal sentiment and content scores and create a vector of 6-dimensional vector for each of these accounts. And I use this 6-dimensional vector for each account to create an embedding. So I project each of these accounts into a point in this 2-dimensional space. So what UMAP is trying to do is if two accounts is closer to each other in the 6-dimensional space, they try to make sure they are also closer to each other in the 2-dimensional space. And in this visualization, each dot is corresponds to one account, and the color corresponds to their overall Botometer score. So even in this 2-dimensional representation, we can see the human and bot accounts are separated from each other in this representation. We can also visualize different things, like we can repeat the same thing and color them by their non-English score. We see similar separation as well. Or we can go to subscores, but this is kind of like a tricky because I'm already using that subscore to create the embedding. So this is kind of like a sanity check in that scenario, whether the UMAP is capturing some structure, and it does. Like if the user feature is also high, they can also be seen in the red part, or for the friend feature, the accounts with higher friend bot scores is actually located in different parts of the network, or in the content feature. So we see an overlap of the bot accounts in general that we see, but there are some human accounts that look like more bot-like in terms of the content they generated, and here we can see those, or the sentiments. So probably those are the English language accounts that we ignore, or we couldn't, Turkish language accounts that we ignored their content and sentiment languages. They kind of like appear in this part of these embeddings. Or the temporal features. So temporal is very well aligned with the other overall bot score, or the network. We can also see similarities. And we can also do other sanity checks, like in the following 3 embedding, I'm using the follower scores and follower numbers and look at their percentile. So if you are a really popular account, you appear in the top percentile, or if you are not really popular, you are appearing in the lower percentile. And that figure basically says is the number of followers is not a good indicator of whether an account is human and bot. We can see they scatter across all the embedding space. So we cannot simply use follower count alone to detect a social bot, or similarly for friends or the number of status. And that's kind of like these 4 is kind of like seeing it is not so easy to identify those accounts relying on these features alone. But it is quite nice to be able to see like how well the bot accounts and human accounts are separated in this embedding space. Like we have it here. Okay, so so far, like we have been building on the data and tool sets that we have been developing. So first, what we did was we collect hashtag concurrence network through the OSoMe platform in their network visualization tool and the trend tool to look for the activity rate. And then I go and collect tweet IDs from my internal resources from the Deca house. And then I share those tweet IDs. And with these tweet IDs, we can dehydrate and collect all these tweets using TweetPy. So here, the first, I think, crucial tool that we use for such analysis is the TweetPy for getting data from Twitter. And since we are interested in the different accounts on this complex network, how they interacting with each other, we want to look at for the bot accounts. And the Botometer was a tool that I recommend for using. So Botometer has an easy API that we can get additional metadata about each of these accounts, and Botometer scores is one of them. So now with this last notebook, let's take a look at like what type of networks that we can create from such data. And this is the network notebook number 4. And I did a couple of simple things with that data. So the first one is we can build networks through these available metadata. So first, I built a network of retweet mentions and replies. So this is a code that I created a directed graph, because for Twitter, anytime I retweet, it indicates a direction. And I use this direction in a way the same direction as the information diffuse. So if I retweet another person, I am transmitting that person's information to my network. So I put the direction from the other person that I'm retweeting to myself. So I get a higher in degree if I'm retweeting someone. And if I mention someone, it's going in outgoing link, or if replying someone, it's an outgoing link. So I kind of like look for how the information diffused to decide the directionality of those edges. And for each of these tweets, so I create a function called iterate tweet content. So which is this, is simply reading the file line by line and parsing each of these tweet records. And for each tweet, I extract different connections. So one connection is if whether this user is replying to anyone, looking for, retweeting behavior. So whether someone is retweeting another account. Is there anyone mentioned in the tweet? So I collect the mentions. And I add all this information to my network, and I use like the retweet count, mention count, and things like that to keep track of these details. And then since in the parallel, I was collecting these user profile for each data, I can also complement my network. So in my network, each node is a user. So I can add additional metadata about those users. I provide number of friends, followers, status, and things like that. So screen name, the creation year, to increase the available metadata for each of these nodes, which can be useful for us to visualize those networks. We can use this information to color the nodes or change the size of the nodes, as Matthew was mentioning in the morning. So these can be useful information for creating different network representations, different network visualizations. Here I've been reading Botometer scores to provide also additional bot scores onto network. So for each of these accounts, each of these nodes in the network, I check whether I have a Botometer score available. If that's the case, I'm providing it. Or if those accounts are one of the accounts that I cannot access because they are deleted or suspended, then I give them a -1 Botometer score, and I can keep this score in mind when I was visualizing this. And I did actually another trick here. So instead of visualizing the Botometer score as a continuous value between 0 and 1, I discretize it. So now they are getting numbers, integer numbers 1 to 5. So with this way, I can color, let's say, any account that gets score 1, which is closer to human in that case, as blue. And if they get 5, which is a higher end, and then we can color them as red. So it will be more distinct color values for each of these nodes. And okay, so far we built the network. Since the network is large, I kind of like clean some of the low degree nodes here. So any node that has less than degree 5, I remove them and store them in this filtered network. And I think that was the network, I believe. So with these, what we have is like, and this is not like a perfect network visualization, but what we have is different accounts. I visualize the name of the accounts that has high degree. So we can see Süleyman Soylu's account in the bottom. I can see Egemen Boş. I think Süleyman Öz. So these are the in the blue group, blue cluster. So those are the prominent accounts in that network, which has high degree. And then there is this bunch of red and yellow accounts on the bottom. And those are the bot accounts that we have. So they get a Botometer score greater than 0.6. And they mostly communicate with each other in this network. They retweet or mention or reply to each other. And it is good to see like such segregation, to be honest, in that network. And okay, so through Gephi, what we can also do, okay, let me first move this to the other side. We can also color them based on different profile information, like number of status. If the account creates lots of content, do we see them clustered in certain parts? So the status figure on the right top has like more darker greenish color for the bot account. So that means those accounts create more content. They are more active. For the number of friends and followers, they are kind of like more homogeneous. And Emre was asking like, we have 15 more minutes, but we can extend it if we need in a private. Okay, I just noticed that. Yeah, I will try to wrap up in 15 minutes, but I really like to discuss for the other suspension accounts if people have time or if they want to stick around. So let's see how quickly we can get there. Okay, so with this network, we can also do some other things, like we can only filter the retweet network, or we can only filter the mention network, or we can look at the reply patterns. And in the reply pattern, we can see like these human and bot clusters are totally significantly segregated from each other. And most of these accounts doesn't really participate in any of the replying behavior. So they either retweet or mention other people, but they never reciprocate any conversation. And we can also project the similar network through hashtag user network. And let's see. Okay, so since we have this network, we can build this bipartite network. And a bipartite network is a type of network when there are two different classes of nodes. And in that specific case, there are human user accounts and hashtags. And the edges represent which hashtag is used by which human. So I create an edge only between humans and hashtags. And then what I can do with that is I can look at like hashtag frequency by users. And this is a nice distribution where we have like certain hashtags are not really popular. There are a few hashtags that are really popular, some that are not. And there were also certain hashtags that are kind of like getting significantly higher popularity than expected, and we can dive into those and look at like what they are. Okay, so that's an interesting one. So let's take a look at together on those. So for that particular one, what I did was I look at the top hashtag, the most popular hashtags, and compute a score of bots who share those hashtags, and try to see a distributions of scores, bot scores, for the accounts promoting those hashtags. So these are the top hashtags that we kind of like selected. And so each of these line is one hashtag. So like here, the top one is Sezai Karaca Koç Türkiye'dir. So it gets 103 tweets. And this is the distributions of the bot scores. So they go from Botometer score 0 to 1. And having this in the really left-hand side says many times the human accounts were responsible for creating a tweet with that particular hashtag. And these red dots represent the average bot score. And I rank these hashtags by their average bot score. So these are the top hashtags are the least bot shared hashtags. And as we go down, we started to see the hashtags that are populated mostly by bot accounts. And the red hashtags that we label here are the ones that originally in our data set. So they've been using either keyword milli or yerli in it. And some of these like that are really popular, milli hesaplar burada, it gets about 104,000 times, and average of like still in the human side of the spectrum. And then as we go down, we started to see like the average bot score is shifting as well. So here, those are the hashtags, the bottom ones are the ones mostly promoted by bot accounts. So like follow Friday special, mostly supported by bot accounts, and the average bot score for that was 0.5, which is kind of like expected since follow Friday is like one of these hashtag people try to boost their popularity or connectivity. But we also see like Akıncı 2013 geliyor, Akıncı 2023 geliyor, TC savunma, and then Cumhurbaşkanı Erdoğan, sınav Temmuz sonu. So those are the set of hashtags mostly promoted by bot accounts. So the average bot score for those accounts were really high. Okay, so there's a question. Do bot accounts make more grammar errors? I saw some hashtag with errors. So interesting. And that can be the case, but I see a really interesting instance where bots are making specifically for the hashtag on purpose. And that was the case when family stayed together hashtag was popular in US. And it was a hashtag to support not separating Mexican families in the US. And these families stayed together hashtag was used in that particular way. But what happened was a certain bot group, bot cluster used the same hashtag with a grammar, with a spelling mistake. So instead of family stayed together, one of the L was capital I. And the bots have been boosting popularity of these hashtags so large. What happened was Twitter's recommendation algorithm thinks that it is actually the original hashtag. So anytime someone tried to use that hashtag, Twitter recommend the bot populated hashtag first, then the original hashtag. And many of the celebrity people who wants to talk about this issue is actually redirected to the wrong hashtag. And that was kind of like an interesting how the recommendation systems of a Twitter can be fooled by using the bot scores. But that could also be the case, like hashtags having a spelling mistake can get popularity just because people are retweeting those content or copying and pasting the content. I don't think bots in particularly be interested in introducing these spelling mistakes if they don't have a specific agenda for that. And yeah, Burak says, it seems that some of the bot campaigns go viral, others are not. Luckily, I mean, if all the bot campaigns goes incredibly successful, it will be really bad. I think there is still a chance the way people have been designing those campaigns. So like I was discussing in a paper, how the current ecosystem is similar to the persuasion campaigns in Second World War era. At that time, the politicians or these misinformation engines doesn't have a capability to create multiple campaigns. So they were really sitting down and thinking about like what would be the best strategy, because you have only 1 or 2 shots to create a campaign that might go really popular and influential. And political campaigners have been using those type of persuasive messages. With the social media, it becomes much more easy in a sense to create such campaigns. You can run 10 campaigns simultaneously for different population, and then you can measure their effectiveness and then improve upon those learned messages. So that might be the part of reason, like some of the campaigns are really bad, but over time they can learn from their mistakes and improve. That's why we need tools like Botometer, Hoaxy, and others to combat against the misinformation campaigns. And I think it's quite important to be able to have like such tools to understand what is going on in our online ecosystem. So this is the part of like the tutorial that I have for using Botometer API and the TweetPy API. But I was also analyzing this suspended account. So if anyone wants to stick around and discuss, or if you have time, you can go through this notebook as well. That would be great. Otherwise, I would really appreciate your time, and I hope you find some of this tutorial is really useful. And if you can provide feedback to this survey, it will also really help for me to understand like what were the parts that are good, what are the parts that might need improvements, and things like that. And then the next time it will be much more useful and engaging. Thank you very much for all of you again.
Well, excellent. I mean, based on the number of questions we got from the chat section, this has been one of the most popular presentations that we had. People were really, really engaging. And I think most of the time, Matti and I were talking about this like last year. People from outside the United States are maybe sometimes frustrated that we always use like American data sets to understand these things, and we desperately need non-American data sets to understand how these things work in Europe, in Asia, in Africa. So basically, both Chris and Matt, they also want speakers to basically introduce non-American data sets into data science. So, what is this?
So this is we send you the feedback link, and this is, and we'll share this with you, of course, but this is the feedback that we've been asking for the whole session, and this is for day 5, and these are the responses. So please answer the survey. The link is also in the Zoom chat, and I'll put that also in the Slack channel right about now. So please fill that out before you log out today. And this is just, it should automatically update, so we'll see responses coming in.